Hey, hope you're doing well. Got a new lesson for you today about graphs of proportional relationships. All right, so that's something new to you guys. You haven't graphed anything so far this year, but we're just going to examine graphs and see if they are proportional. And it's pretty simple. What you have to look for is just two things. If it's a continuous straight line, and if the graph passes through the origin, which is the point 0, 0. All right, so which one of these three, if any of them, or all of them, are proportional? All right, well, I hope you figured it out. It is the second graph here. Why? Well, you see that the line is straight. It's not broken like this first one, okay? So this one, not proportional. And also, it passes through the origin 0, 0, right here, this point, 0, 0. Okay? This one is not broken, but it doesn't pass through 0, 0. So here is the graph that shows a proportional relationship. Now, that's the first part of the lesson, if you can figure out which graphs are proportional. But if it is a proportional graph, you can actually write an equation directly from the graph, okay? And that equation will look like what we were doing in the last lesson, y equals k times x, okay, where k is that number called the constant of proportionality, okay? Y and x are variables, so you want to leave them as letters unless you're trying to solve a particular y or a particular x case. Okay, so to find k, from a graph, really you need 2 points on the graph, and with those 2 points, you're going to determine the change in y and divide it by the change in x, okay? Remember, the y variable is also called the vertical variable, okay? So that's the variable that runs up and down, okay? So if you're looking at a graph, the y variable is here, so you're looking at the change up and down over the change horizontally between 2 points on the graph. All right. Now, the neat thing about this is that it's real easy to find k because you always have 1 point. Okay, you always have the origin 0, 0. Okay, so if you want to identify the k value, I would just figure out the change in y and change in x from 0, 0. Okay, and that leads me to the shortcut that I mentioned. When the graph goes through 0, 0, which is true in all proportional relationships, we can find k by just taking any points y and dividing it by x. And pick a point you can clearly read from the graph. So, for instance, if we go up here, I wouldn't use any points along here because I can't see them clearly. But right about here, it looks pretty clear that this point here, and when you read a point, you list the x value first, okay, which is, in this case, 3, and then the y value, which is 5, okay? So you have the point 3, 5, all right? So from this point, you can figure out the k value, okay? So you're seeing how it changes from 0, 0. There's your 2 points, and so k is, just to remind you guys, it's the change in y over the change in x. Okay, now if we're counting from 0, 0, the change in y would be 5 over 3. And then you could divide it in your calculator and get the decimal equivalent for that. Okay, so that's in the nutshell what you want to try doing for these problems. Let's look at a little example of how we can use it here in a real-life situation. We're going to the county fair. Okay, so here's a graph that represents the prices of tickets and number of tickets at the cost of the county fair and the cost of the county fair, okay? And so it gave you all the points here on the graph. You could see 1 ticket costs $5, 2 costs 10, 3 costs 15, etc. So to find our k value, we can take any one of these points. It doesn't really matter which point you pick, and you take y divided by x to figure out the cost, or to figure out the k value to help you write the equation. So for instance, you could do 5 over 1, and if you do 5 over 1, you can actually reduce that evenly to just 5. You could have also done, say, 10 over 2. Okay, 10 over 2 is another potential point that we could use to figure out k. All right? And so no matter which k you pick, which point you pick, you will always get 5, okay? Because the change from any 2 points is 5 in y and 1 in x. So even if you did like 2 consecutive points, okay? If we figure out the change in y, it would be 5. And you figure out the change in x, it's 1. So the k value here is 5. Okay. Now that we know what the constant of proportionality is, we can write an equation to describe this graph. And that equation is a very powerful thing. Okay, the equation would look like y equals 5x. Okay, and with that equation, we can figure out the cost of 13 tickets. Okay, so tickets is on the x variable. Okay, so we could substitute the 13 in for x, and we would do 5 times 13, which is equal to 65. So it would cost $65 for 13 tickets. And so the equation allows you to extend stuff out of the graph. It could also allow you to find like places in between points. Okay. So let's go ahead and look at some of the problems in the book. We're going to go to page 194, 195, so you can grab your workbook. We're going to try a couple problems out. All right, so let's check out example 1 here. I already skipped some of it here, but you basically have different times and how many calories you burn. And since it passes through the origin, and it's a straight line, we know that this is proportional. So let's keep playing here.
Step 2. Use the graph to find the constant of proportionality. Find the differences between the coordinates of any 2 ordered pairs. The first point represents 10 minutes and 95 calories. After 10 more minutes, she burned 95 more calories for a total of 190 calories. After another 10 minutes, she burned 95 more calories for a total of 285 calories. The constant of proportionality is 95 tenths, or 9 5/10.
Remember change in y over change in x. Okay. All right, and C, it doesn't really matter which 2 points you pick. The y over x value will always be the same. The change in y divided by the change in x will be the same, even if you picked, say, the origin and the first point. Okay, and by the way, that's the shortcut. Always pick the origin and a point, and then you can just do y divided by x to get the constant of proportionality. Okay? All right, now it says use the graph to find the constant of proportionality. We just did that.
Use the graph and the constant of proportionality to find how many calories Tanya burned after 15 minutes of exercise.
Okay, so now
shows that the number of calories is close to 150. Now remember that constant of proportionality is k, which is equal to the ratio y to x. An equation that represents this relationship is y equals k times x. Which variable has a value of 15?
So we are going to pick x, because x is the minutes. That's 15.
Substitute 9 and 5/10 for k and 15 for x. Then simplify. Y equals 142 and 5/10. So Tanya burned 142 and 5/10 calories after 15 minutes.
Remember, we put 9 and 5/10 in for k because that was the constant of proportionality that we determined by taking the change in y variable divided by the change in the x variable. All right, let's try the try it problem here. All right, I'll give you a second to try it, and then we'll go over it. Well, I tried to put the points on the graph and draw a straight line. They give you 1/4 cup is 3, so there's a point there. And if you double that, that's 1/2 cup is 6. Okay, and so if you connect those dots, it does pass through the origin. It is a straight line, so it's proportional. And now we can determine the k value here, okay, by taking y over x for one of our points here. So we could take 3 over 1/4. Okay, that would be this point here. Or we could do 6 over 1/2. How do we take 3 over 1/4? It's really 3 divided by 1/4. And remember, if you divide fractions, you do keep, switch, flip. So it's really 3 times 4 over 1. But 3 times 4 over 1 is just 3 times 4, because 4 over 1 is just 4. So that's equal to 12. So our k value is 12. So to represent this with an equation, we could do y equals 12x. All right, and so if we have 1 cup of cereal, now that we determined the equation, we can do 12 times 1 is equal to 12. So there's going to be 12 grams of protein for 1 cup of cereal. 12 times 1 equals 12, so 12 grams of protein for 1 cup of cereal. All right, hopefully that makes sense to you guys. Let's check out example 2 here real quick. Okay, so this graph shows a proportional relationship. Mr. Brown drives. What do these points mean? Okay, so Mr. Brown is driving in a car. Time, distance. Let's see what these points mean. Okay, 0, 0 means Mr. Brown drives 0 miles in 0 hours. That's kind of obvious. 155. 1 hour is 55, 1 hour is 55 miles. 275 is 5 hours is 275 miles. Okay? Okay, so what is the constant of proportionality here? Well, we could use this 155 point to figure out the constant of proportionality. Remember, how do we determine that? We take k equals y over x to determine the constant of proportionality. Okay? So here, k is going to be equal to 55 over 1, and that will determine the constant of proportionality. And so y is equal to 55x. Okay, and that's the equation we could write once we figure out that k is equal to 55 over 1. We can then reduce that to just 55, and so our equation is y equals 55x. Okay, and so that equation models this whole graph here, and we can use it for some interesting things, like figuring out the time it would take him, or how many miles he could go in 10 hours, which would be 55 times 10, or 550 miles. So that's kind of a powerful thing here. All right, so let's read this problem and see what you guys can figure out. So we're asked to figure out the y-coordinate if x is 7. So 7 hours, how many miles? All right, so all you got to do is plug in 7 for x here, and then just do 55 times 7, and that's 385. So 7, 385 would be on the graph somewhere off this window here, and that would mean that Mr. Brown drives 385, sorry, that should be 385 miles in 7 hours. And I guess I can't write in those blanks there. So 385 in 7 hours. All right, so hopefully that one makes sense. Remember, once again, you're finding k by taking y over x. I keep on reiterating that fact on all these problems. Okay, so explain why each graph does or does not show a proportional relationship. Well, what do you think about the first one? Does it? Does it not? It is. A straight line passes through the origin. Second one, does it? Does it not? Not proportional. The graph is straight but does not go through the origin. And the last one, proportional or not? Not proportional. The graph passes through the origin but is not a straight line. Okay? So there you have it. Basically, if it is proportional, you can figure out the k value by doing y over x. Okay, so like if you're looking at this one, you can figure out the k value here is, this point here is 2, 1. Okay, so if the point is 2, 1, that means the k value, okay, so I got that 1/2 from taking, okay, this is 2, 1. I got 1/2 from doing k equals the y value, which is 1, over the x value, which is 2. Okay? And so once you have k, you can write that nice equation and then do a lot of stuff with it. Okay, so that's it. Hope you enjoyed the video, and have a great day, guys. Bye-bye.